Hello, all. Today, we're going to talk about something new, something great, and something which is out of the world. Out of the world for all the people who don't know about it. And a very common thing, but a very big secret sauce for a lot of architects and designers. We're going to talk about parametric design. But before that, I want to talk about how everything today is computerized. You want to book your tickets? Computerized. You want to do banking? Computerized. You want to get into a relationship? Computerized. And now we're going to see how architecture became computerized. Initially we had drafting tools like AutoCAD or computer aided design, where we made the first step towards, outsourcing our hands. So computer became our extended hands. Then later, what happened? We started to do 3D. So all our views became through the computer. Then later, we went a step further and took BIM. What is BIM? Santrupti, you want to answer what is BIM?
It's building integration management.
Brilliant. That means, all the services, all the different parts of the building, you join together, and, all that is done in the computer. But today we're going to talk about something out of the world. We're going to talk about how not only extending your hands, but extending your brains. We're going to let computer think for us, and that thinking is done by parametric design. So we have today with us Santrupti Das. Santrupti Das is a budding architect who's just completed her bachelor's in architecture, almost completed, from the School of Planning and Architecture, New Delhi. She's a very enthusiastic person, and does a lot of origami. Is actively involved in a lot of societies. Was involved in societies in college, and is did a very great thesis project, and in her project she used parametric design. So today she's going to be talking about parametric design. So Santrupti, how are you?
Thank you. I'm really good.
Great, great. So what is this parametric design, and I mean, how is it done, and what are the software? Can you just start telling us about it?
Okay, so parametric design, let's try and break this word apart. Parametric comes from parameters, or parameters would mean certain rules that you put to define a certain system. For example, the very basic parametric design that we see in our everyday life is the way we arrange our cupboards. So if something looks like a shirt, which means it's to be worn on the top of your body and on the top half of your body, you fold and keep it in one rack, and something that looks like a pant is kept in a different rack. For a woman, it could also add on to, let's say, a sari or skirts or dresses. So all of them are segregated according to certain parameters.
Oh,
Now,
okay.
if you look at a bookshelf,
Okay.
and let's say it's a bookshelf of a very avid reader who collects a lot of books. So then they could have arranged all the books according to authors. Let's say Agatha Christie's books are in one line, and then Enid Blyton's books are in the other line. So that could be a parameter. Authors could be a parameter. Then let's say a child rearranges this entire thing and is not able to read or understand the names of the books, and what they do is they arrange it by the sizes or by color. So size, color, authors, all of them are basically parameters for
Parameters.
arranging your books. So
Absolutely.
when we talk of architecture and parametric design, parameters are basically those characteristics or those features, the criteria that you use to define a certain system in architecture. Let's
Right.
say you start designing a city, and let's imagine a very strange king who says that all the buildings in my city are supposed to be hexagonal in plan, and then the
Okay.
urban designer starts putting hexagons for all the buildings.
Yes.
And then the king discusses with this with his wife, and the queen says that no, I don't like hexagons, I like pentagons. Why can't all the buildings be pentagons? So now, if the urban designer was drafting by hand, he or she now basically redoes the entire process
It is
and
going to be,
changes
it's going to be a
each.
lot of trouble for him. So he has
Right,
to, go and, rub each of the building and make that hexagon into a pentagon. So now,
exactly.
Santrupti, what is the sauce that is going to, help us? Tell us about it.
So that is when digital, taking all of this onto the digital medium helps you, is
Okay.
that you have a parameter which says that all the building profiles are going to be a polygon.
Hmm.
Now, if the king says hexagon, so you put 6. If the queen says nay, it should be pentagon, so you put a 5.
Okay.
And then you tell the king that, go and ask everyone else also for once and all,
Yeah.
and let's find out what is the number of sides you want. And
Yes.
for whatever size you want, I'll do it digitally and I'll be able to create all those variations.
Okay.
Also, what this will help is that I'll take prints, one of what the king wants, what the queen wants, and what other people want in that kingdom. And then I can show them, ki, see, this is how all of these look, and do you want a combination of these? So it's like letting them see the various kinds of outcomes that are possible. So parametric design basically increases the number of outcomes you can show in a defined time. The computer does exactly what we as humans could have done had we had infinite time and infinite processing power. We do have infinite processing power, but the speed is less. So what the computer can do for you is, let's say one very basic parametric exercise that we are also going to do here is to ask you to draw circles, concentric circles, with the first one being of radius x, and the second one being twice that, and the third one being twice of the second one. And you keep drawing these circles. And then I tell you, no, no, it was not 2 times, but it was plus 2. So the first one is x, the second is x plus 2. So the sizes of the circles are going to change. And if you were to do it manually 100 times over, 1,000 times over, then it's a huge task to do. And you would rather spend that time, thinking about something else. So when you say that the computer is an extended brain, the design is still happening, the process of design is something that you are still doing as an architect or a designer, but you are employing the computer to help you fasten the speed of this entire
So
process.
let me put it. So let me put it in another way. So it's like calculator. Using a calculator, we
Yes.
can all do big mathematical sums, but it takes a lot of time to do those things manually. So you use a calculator, and so two buttons we press and we get a result. So it is just
So
like
the
using that
calculator is a parametric machine.
parametric machine, absolutely. And it's just like making computer a nice little donkey of yours who will do whatever
Right.
you tell it to do, at a very
Exactly.
quick speed. So it's like a donkey who will do all the work at the speed of a cheetah and with a little bit of a brain of a orangutan.
Right. So it's very important to note here that although computer is going to take on the task, the brain still stays of the architect or designer. And hence, to say that, you know, it's game over for architects because the computer is going to take it from here is wrong, because the computer still needs the assistance of the architect or the guidance of the architect. And thus it could be convenient to say here that architects have shifted from being designers of space to being designers of systems that can design these spaces.
Absolutely,
And
absolutely,
the
absolutely.
advantage that architects get is that in the time that they could have produced one drawing, they are able to produce so many variations, thousands and thousands of variations.
And which looks spectacular, which you're going to show us right away. So I'm going to just give you
Yes.
the access of the screen sharing. Just 1 second. Participants, give you host. Yes. Please share the screen, Santrupti.
Yes.
So
So,
tell us about what software we're going to use.
okay, so there are many parametric design softwares, like we talked about the calculator being one of the very basic parametric machines on the computer for architectural uh, work. I personally use Rhino and Grasshopper, and Generally speaking, there is Dynamo for Revit, that is a parametric software, and so these are the two softwares that I have used actually. There are other parametric softwares as well
Mm-hmm.
that basically take a code and are able to make the rules for that.
Okay.
So I have shared my screen. Is my screen visible?
Yeah, why are these called donkeys and grasshoppers and rhinos? Any logic behind that?
I am not sure. I think the developers wanted to call them so.
Yes,
Are
because at
both
the
my
end of the
screens
day, they
visible?
wanted to make sure that it's actually an animal that we are taming to do all the work for us.
Probably.
Probably.
Is my screen visible?
Absolutely. We can see rhino on the left and grasshopper on the right.
Okay,
And with
both
so
of them
many
are
buttons which we
visible.
don't understand. Tell us about it, please.
Sure, that's all right. So Rhino and Grasshopper work together. Rhino is the main software,
Yeah.
which is used for 3D model. You could draft basically.
Could you repeat the last line?
What
Rhino is the
advanced?
software.
Yes. So Rhino is the main software here, and Grasshopper is the plugin to it. Um, Rhino is basically a 3D modeling software, but it also opens up opportunities for drafting, and there's a very good renderer on Rhino as well.
Okay.
And the speciality of Rhino, which makes it, in my opinion, a little better than auto. And what that means is that
Better
if
than what?
I
Better
try
than
to make
what?
a
Can you
curve
say from
here,
better?
yes. So Rhino, in my opinion, is a little better than AutoCAD in the way that it uh, helps us to make NURBS curves as well. NURBS curves, I can show you just one NURB curve. So, your curves are much better on Rhino than they are on AutoCAD. You can, and then you can change the control points like this and keep changing the curve. So it's much better on Rhino. Is a
Making
plugin for
curves.
Rhino, and whatever we make here,
Okay.
yes.
Okay.
So whatever we make on Grasshopper basically has, if I just start with a circle, Grasshopper basically has these commands that we can put, and
Okay.
we can zoom in and see what this means. This means a plane. So we need a plane for the circle, and we need a radius for the circle, and it will keep making circles for us. Also, this works on the concept of lists. Like if someone is from a computer science background, they would know what lists and tables and branches and trees are. They basically uh, lists are basically, if you were to make a list of people you want to invite for your birthday, that is a list. But now if you were to make a list of marks of 40 students of a class, marks across 5 subjects, so that's a two-dimensional list. You have the names on one column, like all each row corresponds to one student, and each column corresponds to one subject, so that's a two-dimensional list.
Okay.
So that is how it works. So if I give, let's make a point here, any random point, and I say point, so I'm going to feed this point into Grasshopper here.
Okay.
We can note that this is not exactly a Rhino or a Grasshopper tutorial per se. So we're just seeing one process here. So
Yes.
if I take this point and make a plane, create a plane using this point. Okay, so we have a plane with that point as the origin, and I take this plane into this thing. So I'm able to see this circle here, right? This
So you
circle
have
that
a
is made.
point, and that point is linked to a plane, and the plane is
Yes,
created, and on one edge of the one corner of the plane, there is a circle which you have defined.
yes.
So
So
basically,
let's say
everything
this
that you do in this software has to have a manual feed, which doesn't look like a drawing, but will eventually create a drawing. So you give inputs which are not drawings to get drawings.
was a point. This is the point that was connected to a surface, and then that surface has a circle on one of the sides. So if I basically change this point on Rhino here, the entire thing shifts. So if I change it and the plane, and if I disconnect this, then the circle vanishes. And if I disconnect this, for example, then everything vanishes because the point was connected to the plane and the plane was connected to the circle, right?
So the point was
So
connected to the plane, and plane is connected to the circle. So all need to be
yes,
connected. But
yes.
why do we connect it with the P or the X or the Y or P or the R? How do we make that decision?
So basically, this is asking for a plane, and this dimensions is basically this dimensions and y-axis. So
Your
we are
voice
not
got
concerned
cut. Your
about that
voice
as
got
much.
cut. Can you repeat?
Yes. So the point is being connected to a plane here.
Okay.
So actually, if we just directly connect this point to the plane here, we have the circle there. So
Okay.
a plane works in the rule that P or plane needs a point and it creates a plane around that area, considering the point as the origin. So if I just
Okay.
delete this from here, what we now have is the circle. Sorry. Yeah. The point that we had on Rhino, right? So if I just make a line here for a reference, okay, and I move this circle closer to the line, sorry, the point closer to the line, the circle itself moves. So if I move this point here, the circle moves there. I made that line to just show you the reference, and I'll just delete that. And now we have the circle. Now this is one circle, and it was easy to make on Rhino also. If I just take any draft, like any drafting software, AutoCAD also, Rhino also, a single circle
Yes.
is all right.
Yes.
But what if we were to make hundreds of circles? Let's try and make 10 circles, okay?
Yes.
I'll have a series. So in the series, I need the start of the series, which could be zero, it's all right. Or the start of the series is the first number, first radius that we want. So let's say that the first radius we want is 1. So the first radius we want is 1. The number, the step. So I was talking about each circle being 2 meters higher, 2 units more than the first circle, the radius being 2 units more. So let's type 2 here, and I have that in the step. So it's like the arithmetic progression we used to make in maths. And the count is about, let's say we need 10 circles. A funny anecdote that I remember about parametric design would be that it's for undecisive people who find it very confusing to decide what they want exactly. So
Absolutely.
what I
Oh,
have now are,
whoa. Just by making this little programmable thing, you can achieve a lot of circles made automatically.
now after we make these series, what the series does here is, if I just show you what's there within the series, it's like a, this is like a notepad. So I'll put the answer here.
Right.
So it has started with the first number being 1, and
Okay.
then plus 2, and then plus 2 plus 2. So it's got me all these values.
Right.
But what are these values basically? They
Right.
are just numbers right now. So if
Absolutely.
they were to go into the radius command, the parameter here, which is called the radius, so it has input these values. If you see
Right.
the things in written here in the orange panel or the yellow panel is the same as what is written in the green panel.
Yes.
So it just says that it has taken these 10 values from one
Yes.
source and the values
Right.
are so and so.
Yes.
And here it tells me that there are 10 locally defined values, and what are
Right.
they? They are circles with radius as follows.
Right.
So if I just change, okay, I'll just put a panel here also so that we can see what's out here in the circles.
Right.
Okay, so
Yes.
this has 10 circles
Right.
which have these radius, and these are just values. So if I were to take these values somewhere else also, they would just stay as values and they would become whatever they had to.
Right.
Here, if I increase this to, let's say, 3, you see
Yes.
all the values change.
Ah. Yes.
Okay? And
Absolutely.
then if I change the number of circles that I want,
Right.
okay, so there are 3 circles and then 4 and 5 and 10.
Right.
You see all the values here, everything is dynamically changing.
Yes.
So I have these circles as they are.
Right.
Now, if you wanted, let's say, um, not each of this gap, 1 plus 2 and then 3 plus 2 should not always be 2. I
Yes.
can change that. I could have changed that also and made it much more complex. But for right now, let's just look at this.
Yes.
And I'll just remove this because it's the same as what we're seeing in this panel.
Yes.
And I'm going to move these circles.
Okay.
This king right now wants circles, okay? And they could have wanted anything else also. So
Yes.
I have moved these circles, but I
Okay.
want them to move in something similar to this. Like
Okay.
currently, if I just show you the perspective view of this,
Okay.
what has happened is all the circles have moved to the same distance,
Okay.
right? The green
Yes.
one is a selected thing. So
Yes.
if I want them, if I give them a value of 10 here,
Mm-hmm.
then all the circles together will move. Sorry, I just a moment.
Don't
10 in,
worry.
10 into y axis.
Right.
Sorry, y axis. Yeah. Um, sorry. Yeah. 10 into the y. Sorry, I'm so sorry. This is the z axis.
No problem.
It's the z axis. So 10 units in the z axis and here. So it showed me a red because that was an error basically.
Yes.
To put just the number into a vector,
Yeah.
it's
Yeah.
the scalar quantity and vector quantity. And
Yes.
you see this, everything has moved to the same distance. And if I
Ah.
it comes down, all the circles have moved to the
Wow.
same. But what if I want the first circle to move 1 unit and the second circle to move 3 units? Something like that.
Okay.
So, so what I'm saying is that this 10 or 7, 8, whatever is happening, should have a series of this sort so that I can get something like this. So one
Mm-hmm.
way would be to directly put this series into it. And what you get
Right.
is dynamically this. Each circle is rising in a different way. But currently this series is following the exact rules that were being followed to make the circles. So if I just copy this set of series
Right.
and make a new series here, okay?
Right.
And I can remove this now and I'll move both of these a little ahead. So you see
Okay.
what happens in this series is
Mm-hmm.
that it's almost equal to whatever we were giving there. But if I change
Yes.
values and I say that the first circle is not supposed to rise up at all, the
Okay.
first circle is supposed to stay at 0,
Yes.
okay? And then I take it here and I
Okay.
change this. So you see what I'm getting here.
Right.
When we had this as 2, we were getting almost a 45-degree angle here. But
Right.
now we get something which is like this,
Absolutely.
okay? And
Yeah.
if
Yeah.
I
Yeah.
change things here, everything is dynamically changing. So let me
Okay.
just hide these circles for the moment. We can hide anything at any point. And
Okay.
now if I dynamically change this, you would see the difference. It becomes
Okay.
flatter, it becomes ball-like. So if I,
Yeah.
okay, and then let's try and loft all of these.
Okay.
So loft. Let's loft all these.
What's loft for the viewers?
Yes,
Is
so
to give
loft,
it a plane.
yes, it basically starts to imagine a plane between two curves and then between three curves.
Right.
So now we have this. Look at this
Okay.
green cone that we have, and we can
Looking.
change
Yes.
that green cone using this,
Yes.
and we can also change that green cone using this,
Right.
and we can also make the green cone rise up
Yes.
like that, or we can make the green cone rise even higher.
Yes.
Like with taking the first point somewhere else. So it
Yes.
has risen. This versus, the green cone moving like that. Sorry, the green
Yes.
cone is not selected. Yeah. So it can keep moving.
Right.
Okay. Now let's remember that king and queen again, and
Yes.
who didn't want a circle now, and they want a polygon.
Right.
Okay. Because a
Understood.
circle is also a polygon essentially.
Right.
So whatever this circle was going and connecting with this geometry here, G. So let's
Yes.
first connect. What is this? This is the polygon, the
Right.
output. Let's
Right.
first
Right.
connect it to G.
Yes.
Okay.
Yeah.
and it has vanished because the circle has disconnected. Now,
Yes.
what does it ask us for? It asks us for a plane, and the
Yes.
plane is this, and the radius. Radius is the same as, let's say, the circle's radius only. We are
Yes.
trying to disconnect and make that. Okay.
Yes.
And number of sides. Now, this is where the queen and the king can fight, and we have, let's say, um, let's go up to 10.
Yeah.
Okay, number of sides. I'll delete this circle from here.
Right.
Uh, I'll just organize these things a little better
Yes.
so that it's less confusing for viewers. Okay, so
Yeah.
this, now when you take this design, let's say, of this tower to the viewer, or to the king and the queen, and you tell them, "Ki, okay, do you want a 10 sided, or do you want a 7 sided? Do you want a 4 sided, or a 3 sided?" You can't go below 3 sided because a polygon won't be formed.
Yeah.
So a 3 sided tower would look like this, a 4 sided would look like that, right? And the last thing that I could show you here is that, if instead of each, let's see what happens when each of these polygons, instead of being the same side, let's say each polygon is a different side.
Okay.
So we have a series again, this kind of a series.
Yes. Yes.
Series is one of the most interesting commands here because, it directly uses logic. And so if I fit this here, see, look at what has happened. It
Yeah. Yeah.
This
Yeah.
is
Yeah.
causing a problem in lofting it now,
But
because
it's like so many different shapes, one on top of the other, like a
yes,
triangle, a pentagon, a hexagon, a heptagon,
well,
octagon, nanagon, and a decagon.
see, now what has happened is the first one is a three-sided figure,
Yes.
and then a four and a five and a
Two-sided
six.
figure, five-sided.
Yes,
Wow.
but
Wow.
we can't start with one, hence
Yes.
it's failing. So what we'll start with is three,
Okay.
because there's an error here. It shows that polygon must have at least three sides,
Okay.
which is a logic that you need to use, and this is where the human's brain is still valued, that you are needing to use. So now you get the correct thing. You get a triangle and then a square, a pentagon, hexagon, and you get this
Absolutely.
complex form here. And this form, as we remember, can be changed using this
Wow.
into a flower. Like, okay, let's do this. Let's hide this polygon here. I can hide it, and let's hide this also. Okay.
Yes.
And finally, we have this, the green thing that we have. Okay.
Right.
And what all are our parameters? The person can either change what the starting profile is. Like, this is a triangle. If the person wants a square, do you see pentagon? And do you
Yes.
see how it changes the whole thing?
Yes.
Yes. So one thing is to change the base profile, and also to change this.
Absolutely.
So here what has happened is, you're getting something more softer and better looking.
Yes.
If I do 0, which means it's a triangle only, because it doesn't
Yes.
change at any point. If I
Absolutely.
do 1, it takes triangle, square, pentagon. If I
Yes.
do 2, it takes triangle, pentagon, heptagon,
Mm-hmm.
like these values.
Yes.
Here, I can reduce this to make it closer to each other. This was
Absolutely.
about the radius, right? This is about
Yes.
radius. So this can happen. This
Yes.
can go, let's say I put a 10 command there to just show you I'll delete this. And now the lowest radius can also change, or the most bottom radius can also change. This can change and open up. And maybe this is a tower, and then this could also work like an architectural space. And at some
Absolutely.
point, it's become a dish to serve something, maybe.
Absolutely.
And you can close this in at 1, or expand it. And
Absolutely.
let's make it back to something which is architectural, which looks
Yes.
like this, maybe.
Yes.
Okay, and bring it closer to this. You can keep playing with this. It's very
Absolutely, absolutely, absolutely. So this is a very, very good example, and for today's video, we have covered like a basis of how the different combinations in this amazing software work. Now, it's not about the software; it's about the thought behind the software. It's about the
right.
logic behind the software, and it's about combining all these together to create extraordinary results. And as you very clearly mentioned, regardless of what the software can do, it's at the end of the day the creativity of the person doing it. So it's the architect, it's the designer who is actually in more control. And by being in more control, it means that you don't have to wait donkey time in drafting, you don't have to waste donkey time in reiterating stuff. That is all being taken care by the computer. All you need to do is just worry about, or just creatively think about what do you want, or what is the different things possible, and out of all the things possible, what is the best solution. So is that right? I mean, how do you
Yes.
do you agree
Yeah,
with
I
what
will
I'm
show
saying?
you the various outcomes that we are doing here.
Wow.
And okay, so we have a now this has lost its connection to architectural space maybe, or it
Yes.
still is, it can still be imagined as architectural space.
Yes.
But basically Rhino is the workspace where it gets previewed, but the code is being written on Grasshopper, so it's important to bake it on Rhino.
Understood.
So maybe you start designing some kitchenware like that,
Understood.
or even the reverse of this probably looks like architectural space or like
Right. This is amazing stuff, amazing stuff, amazing stuff. And I'm sure we're going to make more videos on the architectural stuff to show you actually how you can use this in architecture.
So when I have shown you just three, actually there's so many combinations here. Each thing that you tweak, for
Yes.
each tweak here, you can fix everything else. Like
Right.
for starting with four, starting with three, everything can be changed,
Right.
and you can let the user decide. Let's say now this solves that problem of which is the correct answer,
Yes.
and you get these complex forms.
Absolutely.
Yeah.
Brilliant, brilliant, brilliant. I mean, it's so amazing to see so much great stuff happening. And all the people who are listening to this, you know would be so curious to know how this works, who've not already worked on it, and how they can save so much of hard work and drafting and recreating 3D stuff, and just simply think of what they want. So this is actually liberation for architects, liberation for designers, where they don't have to do the drafting part so much. Of course, they'll have to figure out the commands required to do the outcomes that they have to do, but it's more of thinking and less of hard work, hard work, hard work. So it's amazing to see this parametric design introduction, and I really, really thank you, Santrupti, for telling us, like in such an easy way, such a comprehensible way as to how this thing works. And in the future, we are coming up with more videos on the architectural utility of Grasshopper with so many examples. And even Santrupti's thesis was in this topic. So great. I mean, I'm so happy to have you, and you share this. So please, cap it up for all the viewers and tell us about, just conclude this video for us.
Yes, sure. So I think I got introduced to parametric design in first year, and I started understanding it for origami, basically, to
Right.
make different changes, and that is how maybe my style of origami also evolved.
Right.
And parametric design actually helps you create so many outcomes that you know even if you work for lesser amount of time than others,
Yeah.
you are able to produce that kind of an outcome because of parametric design. But
Smart
then
work.
what it challenges you a lot, exactly, smart work, but what it challenges you is that thinking capacity, because now you have a device or a software that can do that for you. So you have to also upgrade. When the software is upgrading, the architect herself has to upgrade to be able to um, think in that way, to be able to imagine or know, like we talked about those polygons, to know that a building can be more than a square profile or a rectangle profile,
Right.
and to be able to do that. So since it's a new software, new way of designing, it's also important to read parallelly. Like when you mentioned about my thesis, there I was using a certain code which was someone else's thesis. They were also researching, and then I used that same code here for my thesis. So it's important to understand it's basically a confluence of design, of mathematics, of logic. So that is what brings all of it together. Nevertheless, the thinking mind of the architect is still paramount to all of it.
Absolutely,
And
absolutely.
last thing I think, which is my favorite, is that I really love the interface. It's
Right.
so, user friendly in the way you keep playing with it. You join things, remove things.
Yes, yes.
The
It's
colors
like
are beautiful.
very, very beautiful, way of working, and you can interjoin things, and keep playing with it, keep exploring different ways. So great explanation of parametric design with a
Thank
very
you.
nice example. Thank you so much for sharing with us, Santrupti. Thank you.
My pleasure. Thank you.